So to begin with here today, we're going to start with talking about more vector addition and subtraction. So let's start thinking of them more as an XY axis. Everybody draw yourself one of those, and then draw this. And we're going to say that this goes over 4 and up 3. Then that vector does not have a length of 4 and 3, but it's described as 4, 3. And I'm going to call it A just to keep it simple. That's going to be called A, and I'm going to put a little vector thingy over it. That's vector A. How long is it? And what's its official name? No, not A. What's the name for length? Don't say it out loud. These are the first two questions that you're supposed to already know. Introducing the B vector. It's going to be 0, 1. If you know what this symbol means, you'll be able to do that to the B vector. Number 4. You should be able to figure out what's the A vector plus the B vector. No, it's not the C vector. Number 5, what's mass without, don't say it, it's a question that you have to answer. Mass without direction. Don't say it. Write it. Number 6. What the heck is the 0 vector? No, 5 is not the 0 vector. Pause for a second while you answer questions 1 through 6. All right, so the length of ray A was, well, you could say this was 4 and this was 3, and then you might know the 3, 4, 5 triangles, so this is 5. It isn't always going to work out that slick. A lot of times the answers are square roots. That one is the square root of 25. Name that length. That's called the magnitude. How many of you remembered the word when you needed it? Magnitude. Those little bars right there are saying find the magnitude of B. Well, since it's going straight what? Up or down? Straight up, because positive is up. It goes over 0 and straight up 1. Now I've drawn it, tip to tail. Its magnitude is 1. It's really simple. It's a straight line that's going in an exact direction. I don't have to do like a triangle to figure it out. But the resultant, I would. Here's the resultant. And that's over how far? Look, I can see it's over 4 still. And up how far? It was up 4, now it's up 1 more, so now it's up 5. Another way we could do that is this plus that, this plus that. If I said 5, I know I said 5, I'm wrong. It's 4 plus 0, 3 plus 1. That's 4, 4. All right. So that's the name of this vector. I always put a fraction bar in there. 4, 4. But how long is it? Square root of
32.
Square root of 32. 16 and 16, square root of that, square root of 32. So if you thought I meant the length of it, it'd be the square root of 32. But did I say the length of it? No, I didn't put bars around this thing. If I'd put bars around number 4 like this, then you would have needed to say its magnitude. But I didn't put the bars around it, so you should have just said that it was 4, 4. All right. What's mass without direction?
Zero vector.
Nope.
Scalar.
A scalar. And the zero vector, I'd like you to just, I told you before that it could be any direction with zero magnitude, but it is best understood as just no direction and no magnitude. Because you have to have something that happens if you have two vectors that meet like this. And when you put them tip to tail, it's going to be like that, and it's right exactly back where it was in the first place. You have to have some name for that. It's like if I'm blowing on the volleyball from this side at a certain force, and you're blowing on it from exactly the opposite side, it stays still. The answer is like 0. It doesn't move. So we need zero vector to just be 0. And you could think of that as, yeah, if you moved in a direction that had 0 magnitude, because you didn't move any distance in that direction, it'd still be the 0 vector. But best to just say no direction and no magnitude. Okay. I feel like you understood that, but I need to find out. Now let's talk more about that adding and subtracting vectors. Let's do a subtracting vectors. Would you please take 5, 1 and subtract the vector 2, 1. And I'd like you to draw what that looks like. Draw the resultant and tell me what the resultant is in column form, but draw me the picture because I think you need to see it. Yeah, you could just manipulate some numbers but not really know what your drawing would look like. Okay, so draw this. Okay, here we go. So you go 5 minus 2 is 3, and you go 1 minus 1 is 0. 3, 0. What would that look like? Well, it'd be a resultant that would be going 3 to the right, but not up and down at all. So it kind of looks like this at the end. Well, I'm going to actually draw it to make sure I get that. So if I go over 5 and up 1, put a dot there and say, that is my first vector. And I subtract 2, 1. Normally, 2, 1 would go 2 more to the right and up 1 more. So here's normally 2, 1. But this is not normal. This is going the other way. 2 back this way and down 1. And so look at that. It's hitting exactly where we said it would at over 3 and up 0, which I'll make it the black vector. There we go. And how long is that vector? That's pretty easy. 3. Because they don't have to make a triangle for it or anything. That make sense?
Yes.
Okay. Let's get to the notes. There's a few good ones in here today. So.
Why is this flying related?
I know, it's a bird theme.
Why?
So.
But there's also planes, so why is this flying related?
Well, because you can finally do 3D. Think of it that way. Because now we can have birds that don't just go over and up. They can be like going over, up, and backwards. So once you got 3D, you can explain a lot of different situations. Okay, so back to this. Would you please look at these as vectors? And they're asking you to figure out what's vector AB plus vector BC. But then there's these bars around it, and hopefully you know what that means. Please figure out the answer. And yeah, I know that the angle's important. No, you shouldn't just assume that that's a 90-degree angle. I'll pause for a minute while you figure out the resultant and the answer. Go.
Just stretch.
All right, so this is your resultant, and it is how long? Well, this line was 15, and this line was 10. Square root of 15 squared, 225. 10 squared, 100. 325. Raise your hand if you had that. Awesome. And that is the magnitude of that vector. Now, if we were giving it a name in 3D space like this, that would be totally different. I hope you figured out that this was, since this was a 45, then this was a 45, and this was a 45, so this was a 90-degree angle. That's why we could do that. If you just kind of didn't even think about that, you should have. And you should have determined, yes, it is in fact a right triangle. Otherwise, you'd have to use one of those other formulas. So imagine for a moment it was like this, and I just want to jog your memory on these. Let's say this is 100 degrees. and this is 10, and this is 7, then I want to know how big would this angle have to be? And I know that this involves like an answer to like sine of 50 or something like that. So give your answer in terms of that. Hint, you'll need to use the law of sines. Pause for a second while you figure out the question mark. So we're going to start with which formula should you use? Somebody's got this. Raise your hand if you know which formula you're supposed to use for this. Yes?
Be cosines?
You could, because the law of cosines is the boss and it works for everything. But you could also use the law of sines because we have an angle and we have the side across from that angle. And if you just have one more piece of info, you got enough for law of sines. So everybody, at this point, if you didn't know that already, which I understand, I now want you to take it from there. Sine of what over what equals, finish the law of sines, sticking in the right things here. I'll pause for a second and give that a try. All right, you should have said sine of 100, which I totally get you're not going to know off the top of your head, but you can keep it in your answer, over 10 equals sine of the unknown angle, but wait, the unknown angle doesn't go across from the 7. So first, you'd have to figure out the other unknown angle, which I'm going to put as question mark, double question mark. Sine of double question mark over 7. Do you get that we're going to figure out this one first? Does that make sense to you?
Yeah.
And once we've got that one, do you get that we'd know that this one plus this one adds up to 180? All right. So I'm going to times both sides by 7. And how do you get the sine off of there? Yes, sir.
Inversely.
Yep. Inverse sine all that means that we've now got our question mark alone. That is an angle. And whenever you have an inverse like going on there, your answer to it is going to be an angle. And then I can say that 100 plus question mark plus 1 question mark equals 180. So I could also say that double question mark is 180 minus 100 minus question mark. $180 minus 100 is easy. That's 80 minus question mark. So when I have this answer, that answer is 80 minus question mark. So I'm not going to finish it, but I think you could see that we could get it as long as we had a calculator.
So are calculators allowed in this test?
It's an excellent question. What if we had a problem where this wasn't 100? What if it was 30? Could you figure out the sine of 30? I want you to just go off to the side for a second. And sine of 30 is maybe a little too obvious. Some people have memorized it. Let's say that sine of 60 was in the question. Would you be able to make a 30, 60, 90 triangle and figure out the sine of 60? I hope it's not that bad. $30, $60, $90, 1, 2, square root of 3. What is the sine of 60? 3 over 2. What is the sine of 30?
1/2.
Yeah, you should just memorize that one. It comes up a lot. Sine of 30 would be the opposite over the hypotenuse, 1/2. So you can do sine, cosine, and tangent of any of the biggies, which is 30s, 60s, 45s. You can also do 90s pretty easy because, you know, like
120s.
the quadrantals. That's just 2 60s. So if I needed that, that's easy. There's sine of 60. All right. So, boy, this is starting to look like homework. Do you think you actually should do this homework? I agree, you should do this homework, except not this particular problem. Because we really didn't talk about these north, south, east, and west in degrees that much this year, so I don't think we'd do that to you on a test.
I
And
downloaded a compass app for the z-axis thing, so
cool.
I can do it on the test.
This, if you had a calculator or your apps, that's going to be thrown out also. I don't need you to worry about logs today. I did explain it to one class, but I don't think we need to teach you logs. And then we get into vector addition. We've talked about it's always head to tail. And they do mention two methods. I'm going to show you triangle method, which I already did show you. That's where you take B, like they did. I just copied B then over there. And you make the resultant as this red line. When they say make a parallelogram method, that means that you can just go, here's B, and here's B, and here's A, and here's A. And do you get they both end up with the resultant of that red resultant either way? If you make a parallelogram, it goes down the middle of it. Some people will like that better. Okay. We're not going to test you on these, so don't stress about all the properties. You definitely need to know how to do this. And when they start throwing around 2b, do you get that just means it's twice as long in the same direction? So if the vector was in the first place, this vector right here, that's 3, 3. If I said I want to do twice that, don't overthink it. It's just 6, 6. It'll go twice as long in the same direction. And then it just goes over 6 and up 6. Does that make sense? So when you double one of the vectors, it just doubles both numbers. Okay. This is you double this vector, you add it to that vector, and then you cut it all in half. Do it in that order, because you start on the inside and you end with the stuff on the outside. So it's just half as big as whatever it was. So figure out what that vector is, and then just cut everything in half. So how do I do b plus 2a? Well, here's what b looks like. It's one of these pictures. B plus 2a's. Here's b plus 1a. And then 2a's would be like that. Just put them back to back. That's b plus 2a's. Okay. And the rest of the homework is stuff that you should practice. I'm going to tell you this chapter test is the hardest test you have left. In my opinion, the final won't even be that hard, because the final is all questions you've already had on tests before, and most of you got most of them right already this year, and I'll review it all for you for the final. But this unit we're in right now is probably the hardest test we have left. I'm not saying it's the hardest test we've had all year. I'm not saying that. But I am saying it's harder than average, and it's the hardest one we have left. What do we do after this chapter? One last chapter after this one is called Sequence and Series, and that's where you have like summing up from 1 to 100, and you'd have to figure out what that means. Well, I'll just give you an example. You'd go 2 times your starting number, 1, which is 2. And then you'd have the next term after that would be, you put in a 2. And then you put it in here and you get 4. And then you put in a 3, and then you times it by 2 and you get 6. And you get it's a series of numbers, 2, 4, 6, 8, 10, and you just keep doing that 100 times. But then you have to know a way to add them all up, because you definitely don't want to do a 1 by 1. But we just give you a formula for that. So this unit, way easier. We're going to end with sequence series this year. And then you do have a final. And the final has been determined that we are going to make it worth, at least, again, things can change, but at this moment, we're aiming at a final that's worth less than a normal full-size test. Because if we made it worth a full-size test, it would be 1/9 of your grade, approximately, because there's 9 tests typically in a chapter. And that means it'd be about 1/9 is 0.11. That's a lot, 11% of your grade. Now, that's not factoring anything for homework, but to say we factor in the homework and it's worth about 10% of your grade. That's a lot. And the principal didn't want finals to be worth that much. So we're scaling it back. So your final will be worth less than a normal test. So what I'm saying is, if you can get through this one last chapter, give me a few more nights of solid effort on homework, because the next chapter will be relatively easy and the final will be worth like half of a normal test. Not necessarily exactly half, but less than a normal test. So you can get through this test, you'll be in pretty good shape. Okay, so please give me some effort tonight. And that's all I got for the video for today.